This video for AQA Further Pure Mathematics, Algebra and Graphs, section 2.2, looking at inequalities of the form f of x is less than g of x. Well, there are three different methods I'm going to look at for solving this type of inequality. Depending on the forms of f of x and g of x, any one of them may be easier than others, so it really is a case of trying to decide which method is applicable in any particular situation. The first one I'm going to look at is a graphical method where we can easily sketch the graphs of f of x and g of x. So if we did that, then in general we'd have two functions on the same set of axes, two graphs. So for example, this one might be f of x, and then g of x may, for example, look like this. Might just be a straight line, for example. And once we sketch those two graphs, we can find where the two graphs meet. So there's going to be one other, maybe this one is climbing, so there are 3 points here where the graphs meet. So we would solve the equation f of x is equal to g of x. And then having done that, we have got what we call sort of the critical values where things are going to change. So we can then see the solution. If we're looking for f of x is less than or equal to g of x, we want the curve as I've drawn it here to be below the straight line. So it would be from this value of x downwards, so less than that value of x, and then between these two values of x. So that's our general sort of graphical method. Sketch the two graphs, look where they intersect, and then from the sketch write down the solution to the inequality. So let's look at that in a specific example then. So if we solve the inequality 3 over x is less than or equal to x minus 2. Well, we can sketch those two graphs. They're quite straightforward to sketch. There they are. The red one there is 3 over x, and the black line, straight line, is this y equals x minus 2. So both of those straightforward for you to sketch. Remember, it is just a sketch. You don't need to plot these accurately, because we're going to find the points of intersection here by an algebraic method. And to do that, we need to solve the equation which says 3 over x is equal to x minus 2. Well, to do that then, we can multiply through by x, which gives us the fact that 3 is equal to x squared minus 2x, and then rearranging that, x squared minus 2x minus 3 is equal to 0, and that will then factorize as two factors, both with x in them, one with negative 3 and the other one with plus 1. So therefore we've got our values of x equals negative 1, or x is equal to 3. And we can see that on the graph, although you shouldn't rely on your graph to give you the values. Now once we've got those values, then we want to solve the fact that the curve, that's the red line, is greater than or equal to the straight line x minus 2. So we can see therefore that from the graph we have that 3 over x, the curve, greater than or equal to x minus 2. Well, that's from our first value of x, that's x equals negative 1, and below that, so x can be less than or equal to negative 1, or it lies between 0 and 3, but remember that we can't have equal to 0, so it's 0 is less than x is less than or equal to 3. And there we are, just neatly typed out so you can see the solution. Well, the second method that I want to look at involves taking our inequality f of x less or equal to g of x and firstly writing it as something less than or equal to 0. So then we have an algebraic fraction which I can call h of x. So as long as we can combine f of x minus g of x as a single algebraic fraction, then we can proceed as we did in the first video to either draw a graph as we've just done or solve by looking at the sign of h of x either side of the critical points in a table. So these are methods that we've already done, but I'll look at that in an example now. Our inequality 3 over x greater than or equal to x minus 2 by subtracting. So we get 3 over x and then minus x plus 2 is greater than or equal to 0. Then combining the left hand side as a single fraction gives 3 minus x squared plus 2x all over x is greater than or equal to 0. Now I prefer to have a positive x squared when I'm factorizing, so I'm going to rewrite that. So notice there that I've in fact multiplied through by -1 so that the sign is going to change from greater than or equal to less than or equal to. The top line then factorizes so that we get x and in our brackets minus 3 and x plus 1, and we're dividing that by x to give us that is less than or equal to 0. And there it is typed out. Now once we've done that, two different ways you could sketch the graph if you're able to, or alternatively use a table like we did in the first video on this section. So I'm going to look at the table. Remember that our critical values then are at 3, -1, which will give us 0th, and at 0. So the table is as follows. There are the critical values, the areas below -1, at -1 itself, because that will give us 0, between -1 and 0, 0 up to 3, again x equal to 3 where it will be 0, and x is greater than 3. And then the individual factors to give us the value of h of x, whether it's positive, negative or 0. So I'll just start this off. If we're below -1, then each of these is negative, which makes h of x negative. At x equals -1, then x minus 3 is negative, x plus 1 is actually equal to 0, and that one is negative, but that gives us a value which is 0. I won't complete this now. You've done this. You could have a look at that. If you wanted to pause the video and just complete it yourself, then please do. But I'm going to look at the completed table now. So there's our completed table. And you can see each time we go through a critical value where we get 0 or we go through an asymptote, then the sign is changing from negative to positive for h of x. Well, we want to know when this function is less than or equal to 0. So we can see that it's less than or equal to 0 in the first two parts of the table, and between 0 and greater than 3, I beg your pardon, and up to 3. So it then at that point becomes positive. So we have two regions where it is less than or equal to 0, x is below -1, or x is between 0 and 3. But notice it's equal to 3 but not equal to 0, because 0 would give us is at an asymptote. So there's our solution in the region x is less than or equal to -1, or 0 is less than x is less than or equal to 3. Well, the third method I'm going to look at is an algebraic method where we're rearranging the equation, but remembering that when we multiply or divide by some expression, we've got to make sure that it is a positive value. So for example, we can't just multiply by x because that would be positive sometimes and negative others, but we could multiply by x squared because we know that that is always going to be positive. So considering our same equation then, instead of starting off by subtracting the right hand side from the left hand side, this time I'm going to multiply by x squared. So this gives me 3x is greater than equal to x squared multiplied by x minus 2, which then becomes 3x is greater than or equal to x cubed minus 2x squared, which I can rearrange to make x cubed, start there, x cubed minus 2x squared minus 3x will be less than or equal to 0. I can then factorize that. This has a factor of x, and x minus 3, and x plus 1, and that's less than or equal to 0. So we can look at either a graph of that or again from a table, but we've got to remember that we can't have x is equal to 0 as one of our solutions. So we've got the graph to draw of x, x minus 3, x plus 1. Well, it's a straightforward graph. It's a cubic graph. It goes through -1, the origin, and plus 3, and has the standard sort of shape. So those are our roots there, -1, the origin, and 3. And we want to be less than or equal to 0, but we must remember that we can't have x is equal to 0. So this is the one disadvantage of this method. You have to remember that having got to this point here, that although it would appear that x could be equal to 0, it can't because of the initial inequality as 3 over x. So again, if we want our solutions, then we can see from the graph that x is less than or equal to -1, and 0 lies between, or x lies between 0 and plus 3. But it can be equal to plus 3 but not equal to 0. Well, that's the end of this video looking at the inequalities of the form f of x is less than g of x. In the next one, section 2.3, we'll be looking at cubic and quartic inequalities.